Hello. Good evening, everyone. I'm pretty excited to be speaking here in Vienna today. My name is Barbiro, and I'm a Group Product Manager Data Science at Booking.com. Today, I'm going to be speaking about machine learning, personalization at Booking.com, and I will give some examples for applied deep learning methods we have built in the Booking.com machine learning office based in Tel Aviv. So a little bit about myself. As I mentioned, I'm a Group Product Manager Data Science, which practically means I lead product development teams. Those are cross-functional product development teams that work on applied machine learning. Some of the things we are developing are ranking systems for personalization, computer vision, image processing, voice-to-text, and text analytics. In my background, which is split evenly between software engineering and engineering management roles in the US for AT&T, and 7 years as product manager, while in the last year and a half, I've been working with Booking. In my educational background, I have computer science and math as a bachelor, well, starting 16, as told me earlier, and later on, MBA with thesis and practical applied AI for business. In addition, as mentioned, I am leading mentorship for a nonprofit organization called LeadWith, which is geared towards empowering women in tech. Before I go and talk about machine learning at Booking, I want to motivate why do we even need personalization. And to start, I'm going to share a story about the chewing gum industry in the US. So what you see here is a declining graph. You can already understand that looking at the curve. And I'm going to ask you, how is this related to machine learning and personalization? Let me help you a little bit. What happened in the year 2007? 2008, yeah, exactly. So iPhone. The smartphone has been introduced and widespread around those years. And I can help you a little bit more. It was found that there is a strong correlation between chewing gum purchases and people waiting in lines in grocery stores and supermarkets. What do people do today as they are waiting in line in those places? Yeah, checking the phone, exactly. So this has been quite devastating for the consumer goods industry, but it is influential also for the digital companies like Booking.com and any other e-commerce company. What we see, and those are public numbers, we see a shift from consumers using large screens where you can put a lot of information, some of it might be not very relevant for users, to using very small screens and in very short session, intermittently sessions. So people get interrupted as they are on the go. And another thing we realized as a digital travel company is that people would book on the go. They would book their next accommodation as they are on the ride, on the taxi, on the way to the airport. They might book their next accommodation as they are well in their trip. So this is something which has changed the way that we look into personalization. And in general, it should change any perspective of the digital company. We need to be super relevant for people and also be able to engage on smaller screens. Probably more easier question. How many people live in the world today? Yeah, exactly. So it's closer to that. It's 7.7 billion. It's changing all the time, obviously. And then a slightly harder question. How many people travel internationally between countries? Just guess. Yeah, I heard few numbers, like 3 billion and quarter billion, and it's actually based on public numbers. It's 1.45 billion, which is quite an astonishing number. And if you add to it also people traveling domestically, meaning within their country or any other type of accommodation, the mission of Booking.com to make it easier for anyone to experience the world is quite an ambitious one. Given that in the past year, or more than a year, we have added more verticals and more products to our portfolio. Now you can also book flights, you can also book ground transportation, experiences, and you can also be exposed to food and restaurants. So I know you were asked earlier, Those are our numbers, and this is where we are at the journey. So every 24 hours, we have more than 1.5 million room nights booked. And that's, just to get the magnitude, that's more than the population of Salzburg booking every day, and almost the population of Vienna. And the website and every technology and every feature is supported, including customer support, is supported in 43 languages. Why is it so important? Because imagine that any technology which is developed should be supported and consumed by people from not just different languages, but also different cultures and different way to look at things and consume technology. How are we set up to succeed in that? So some people asked me around when we were chatting outside around how teams are structured in Booking. We are structured in those like small boxes, which we have around 200 teams like that, and each of the teams is including all the needed capacity, all the needed roles in order to achieve their mission, which can be back-end development, front-end development, UX design, product, and user research. Most of them also have data science, and the teams for applied machine learning has more than one data science. And each of those team members has an equal vote, an equal voice into influencing for that team features, product roadmap, and in general, the vision and mission. We all team members, everyone on the tech and product community have full access to data and tools. Specifically for machine learning, we have an ability and the infrastructure to generate machine learning models that can be consumed by any other product team or cross-functional team in the company. Why is it important? That teams that does not have the data science or the needed skill set can consume any data science and machine learning models that we developed by our team. And for example, the computer vision product we will talk about later on. And that also allows us for visibility on where this technology is being used and what impact does it make across the company. So you guessed right, this is not a story about chewing gums. This is a story about machine learning. And I noticed that machine learning has been described earlier by different talks today, so I will just give my 2 points around it. The way I perceive machine learning is this is a tool for decision making. Meaning, in the case of uncertainty, when we need to predict some decision or some action, we will use machine learning to do so. For example, as a user is visiting the website, as a user is contacting the call center, we can use information we know from historic data and from everything we know on that interaction with the user so far in order to help them get what they need better. And where do we have machine learning in Booking? So you're probably familiar with this search result page, practically everywhere. So it's not just about personalization. Some of it is demand prediction. Some of it can be indeed personalization of the content, text, visuals, ranking, and other. And it's not just on the front end. So we have machine learning for meta bidding and Google bidding, of course, customer support for workforce management prediction, and chatbot, and many, many other areas in the company. And just to level set about personalization, if you look for the definition of what does it mean, personalization, in Google it will say creating a certain thing to match someone's needs. In the digital world, I'm going to flip it on its head. So in absence of other person to quote, this is my quote and my definition. So personalization is the ability to make predictions and anticipate user needs. And I'm going to stop here and repeat that, anticipating user needs. If in the past we were under the notion that we need to put a survey in front of users and ask them all these questions because this is the only way we can help them, now we can understand from their behavior. So for example, who here is a Netflix user? Me. So, wow, most of you. Going back, if you are long enough, you might remember a time that as you watched a show or a movie, you would be asked to rate that movie or show using star rating. That is no longer the case today. Why is that? Because if you binge watched Game of Thrones overnight, you likely enjoyed that show. And if you abandoned a certain show or a movie and never came back to it, you might have not liked it. It might not have been a match. Similarly, at Booking, the way that you interact with the platform would help us predict and answer different decision-making, different micro-decision-making points in order to what to present to you next and how to help you. And that machine learning part is without being explicitly programmed to do so. But you don't have to start with machine learning to do that. But today I'm going to focus on machine learning and deep learning. And one of the use cases I'm going to start with is recommending destination. We have millions of different destinations that we can recommend to users, which can be a city, it can be a country, it can be a region. And those are presented on our mobile web, for those who are familiar with the mobile web, from the desktop web, mobile application, and also through the email marketing that you are getting. When we need to present that destination recommendation, and we can only recommend one thing, how do we choose which one to recommend? I'm going to talk about one use case and the way that we solved for it. To do that, I will take a step back and explain about sequence modeling. Who here is familiar with sequence modeling? Language models, NLP, I see there are quite a few here. And sequence modeling, by its definition, is a statistical model that assigns probability for a set of different sequences of sets of symbols. For those who are not familiar, I will explain it in a much simpler and nicer way, I guess. So imagine I have an imaginary ball in my hand, and I'm just throwing it across the stage. At any given point, I can stop and ask you, where is that ball going? And you could pretty much easily tell me it goes like that way and predict where it would be. And I will tell you, you just demonstrated sequence modeling, and you will tell me, no, that's just the laws of inertia, and you're right. But what if I will ask the same question for a 4-year-old? They would answer the same without being exposed to the laws of inertia. What happened there is that 4-year-old or 3-year-olds, they observed those type of sequences of moving motions over time, and given 2-3 points, they can already predict what's the next point based on all the sequences they've seen in the past. Similarly, and I'm pretty sure many of you are part of the more than 1 billion Gmail users and familiar with Smart Compose, as you will start typing in your email for the first word, you won't get any prediction because the probability and the uncertainty is so low, is so not above the threshold. As you will write a word or 2 words, depending on how likely, how popular is that sentence, Gmail will already predict what's the word for you. How is it doing that? Because of the sequence modeling, because the probability of how are you is much higher than any other word in that sequence, like how are bookings. What we found out, which is a surprising thing, is that trips are sequences too. So looking at our data, and this is for Italy, just by looking at the data, we know that people are traveling this way, and this is exactly a sequence that came out of the data. And it can be due to the way that roads are built, due to transportation, due to travel books or travel guides. But this causal effect does not need to be modeled into our decision systems. This is actually going to be guiding us other than any other sequence that I just made up. How are we going to use that? So in an unsupervised way, we can even know that if a traveler has visited Venice, Florence, and Rome in one trip, they are magnitude times more likely to visit Naples than Milan. Why is it important? That if we want to suggest that traveler as they are on their phone and throughout the trip or planning for the trip, if we want to suggest one place, we should suggest Naples, because Milan might be, in some other case, when we have no information, it might be more popular, and that might be likely the place we will suggest, but not Naples. We can coin it as the road trip problem. As people are planning trip over multiple destinations, we want to help them extend the trip or fill up gaps. How did we build this model? This is running live in production. We took tens of millions of those different sequences for top 50,000 destinations, clean up this data from consecutive city stays, then batch them by length of sequences for computational, to make it simpler on computational complexities, and then trained it. The way that we trained the models is we took all those sequences, those N destination sequences, train the n-1, while the nth destination, the last one, would be the target function we are trying to predict for that trip. Just a little sketch of the model and the way that we build the embedding vector. Embedding vector are unique representation, vectorial representation, like numeric ones, that are built to represent those destinations. And the way that we trained it allowed us eventually to visualize even how people traverse the world. So this is a map, which is not the geomap. This is how people travel through the Cyprus Islands. And it might not be true to reality, to the geomap. This is more of how people are likely to go from one place to another as the places are closer together. Interesting to see the Middle East. So for example, you could see here, if for those who are familiar with how the geomap of the Middle East is built, this is different from how the Middle East geomap is built. And where do you see it on the website? So back in September, I traveled to Amsterdam. Those were the dates. And I planned to go to Copenhagen after that. While I was planning my trip, I got those two recommendations, one in the Gap and another one to extend my trip. So back then it was the future, now September is the past. This is just how time works. But when you will have future trips, and as you will plan your trip, we will help you plan it better and based on what other travelers has done. And just to motivate you to use sequences, sequences are not just in the travel industry. So imagine that you are on a digital company and you want to predict when people will close the page. When are they going to make a reservation? When are they going to contact call center for which issue? That's actually patterns you can find in the data. So in those, you can use recurrent neural nets for sequence modeling. Then the next topic, which is shifting to computer vision. But computer vision is inherently also tied to how people observe visual content and technology. So taking you a little bit step back to how Booking.com looked like in 1997, then 2005, and today. Well, fortunately, we have evolved. And as you can see, the website became much more visual. Where are all those visuals coming from? We have hundreds of millions of photos in our storage. Most of them are from the accommodation partners, which are hotel owners, hosts. Many are from the guests. As you will submit reviews for your accommodation, you will also submit images. Many are destination photos, and now that we are also supporting attractions and new verticals like food, those are also going to be included in those photos. What can we do with those photos? So there are a lot of business-driven hypotheses. So the way we build machine learning is start by what is the hypothesis we are trying to solve, and then go back and think what's the machine learning technology to support it. So imagine we understood that customers care about how the food looks like at the property they are staying. Imagine that we realize that some facilities are so important that we need to enforce that partners, or that the accommodation partners, would upload them as they describe the property. Some of the photos are very contextualized and relevant to how people will travel, if they will travel with small kids or as a couple. And some of them are very necessity in order to describe the same property in different time zones, in different times in the year, in different seasons. So this is the same property in the winter and the summer. And then once we understand what we want to present, there are different questions. So for example, we realized that swimming pools are very important for people in order to make a decision. So this is definitely a swimming pool. This also can be considered a swimming pool. Is this a swimming pool? Can we allow it on our website? And then what's that? That definitely is a swimming pool. But is that a swimming pool? Should we present it? So there are so many different questions we need to answer around the quality of the images. And then comes the inherent problem. While we can see this photo and very easily describe it, well, computers do not see. I mean, this is just the problem we are facing every day. They just get files with pixels and RGB values associated to each one of them. The way we solved it is using we started by using an off-the-shelf convolutional neural net like this one, like VGG16, and do transfer learning. So the way that this algorithm is working, it's scanning photos in multiple layers and extracting features out of them. At the end, it generates, and this is like the blue part, it generates a one-dimensional vector, which is a unique representation of that photo that can be mapped to classes. What we did is we mapped it to domain-specific classes that we care about, starting from practical things like, this is a terrace, what's the view? Are there people on the photos? Is there food, drinks on the photos? But then also more abstract approach to it. What's the vibe on the photo? I mean, if we can explain or at least describe it using classification models. One practical example of what and how we use that is, for the example, this one photo is from an hotel in Tel Aviv, where we extracted swimming pool, view, and sunset sunrise from it. As you would go and visit that hotel page, you would see, as you would browse through the photos, there would be the text which would be appearing next to the review would be changing. Because what we realize, and this is tied to how people consume technology and consume visual content, they care if there is a match or mismatch between the text, the textual content, and the visual content. And here we actually used a technique which is combining convolutional neural net, which is the technique to understand what's in the photo, with language understanding and topic extraction from positive reviews. Similarly, in this hotel, we could also extract that this photo includes beaches, and that's what people were rating about. And then another thing we need to understand, as we go and we are trying to make it easier for everyone to experience the world, we need to understand that some users are vision impaired and they are not using the technology as the same way we are using technology. So to enable them to have more immersed and better experience with the product, we introduced descriptive text for those photos. So as they browse through the visual content, they can understand better the feel of that property. Going back to that convolutional neural net generated embedding vector, so what's so special about this numeric representation of a photo is as we take many of those, we can compute distances between those vectors. Distances between photos actually mean how much likely those photos will be similar to each other or not similar. And this is just a visualization for some of the photos, but where are we using it in Booking? You can go on our website, and as you will browse through the different photos of the property, what we did is we are helping people with decision-making by showing similar photos which were taken by users staying at the same property. Without asking the user submitting the review, where did you take that photo? Is that a bed or not? We are just using that similarity measurement. To summarize, I did talk about machine learning a lot and personalization, but those does not overlap. There are a lot to do with personalization, which is not just data science. So some of the UX copy, which is copywriting, all these titles, what we write, how we write it, translating it to so many languages is crucially important in order to succeed. Then the way that we laid out our prediction, the way that we laid out the interaction with the user is also important, and notice that as you browse to the website and mobile app. And lastly, this is something which I haven't touched, and it's very, very important to understand as we introduce machine learning in such a large scale, that the latency of that complex computation might get the website slower. The pipeline to collect data might be complicated. So this is where backend engineering, data infrastructure, and performance monitoring comes into play. To summarize, as Yoda said, you have the power, use it wisely. Thank you.
Thank you very much, Noah.
Yeah.
We have time for some questions.
Okay.
Let's just start with the first one. So DataBuy asks, what models and loss functions do you use for destination prediction?
Okay. So for the destination prediction, the one that I described earlier for extending your trip, We are using the recurrent neural net, and I did mention that we did the generation of the embedding vector as a joint training with the target function of those sequences as the nth destination. Hope that's helping.
Data boy, does that answer it? Yeah, I think so. OK. And the next one we have is, OK. Are you also applying techniques to prevent fake reviews to be posted to your website?
So all the reviews are reviews from people who actually stayed at the property. This is definitely something which is a priority for us, to make sure all information and all content there is authentic and real.
Thank you.
Yeah.
Another one from DataBoy. He's prolific. Do you use transformers for sequences modeling?
We can take it offline.
OK. I don't understand what that means. OK, which machine learning framework do you use for your machine learning purposes?
Wow, this is a really good question, because the thing is, and this is important to understand in a company that has so many diverse people with such a diverse background, and actually not even all situated in the same place. I'm based in Tel Aviv. There are people based, most of the people based in Amsterdam, and then also people in Manchester. So some come with their preferred machine learning framework, and we allow it all. So our infrastructure allows interaction with different cloud providers and different development languages. If I would have that slide of all the different languages that we use and allow and the different framework, it would be amazing. And all of those are hosted simultaneously.
OK, thank you.
And
OK, the next one.
Next one, and I think that would be the last one, looking at the time.
Sure.
Yeah.
So the question is, how do you label the many photos for training? For example, social vibe.
Social vibe is an interesting one, an interesting case, because it's so subjective. In some of the photos, let's say we're talking about, well, swimming pool is also subjective, as I presented. But let's say we're talking about a bed. The guidelines of what is a bed is pretty consistent, and the people who would be guided to annotate this is a bed or not would not have a disagreement. On a social vibe, we had to take a different approach, in which also introduce an agreement level, which means we take a data set and we expose it to every given photo would be exposed to more than one person, and then we will compute the way that we would get to the highest agreement based on the guidelines we provided. In many cases, we had to intervene and actually answer the question, if this is this social enough? And in some cases, we were not uncertain ourselves, but as you take a large data set and diverse people that annotate, so this is also important that you understand the background of the people that decide if this is social or not, and have them as diverse as possible, you will get to a good model which would be trained based on that.
OK, fascinating.
Yeah.
Thank you very much. So once more, a round of applause for Noah. Thank you.
Thanks.